Hi everybody. Happy to meet one and all during this session. Hope everyone would have understood and enjoyed the first two sessions. Earlier, we have discussed about the elements, compounds and mixtures and the various techniques adopted to separate mixtures. In this module also, we are going to see some other techniques used for the separation of mixtures. Today's topic is simple distillation, fractional distillation, adsorption, absorption, chromatography and paper chromatography. Every one of you attend this session and learn with joy and ease. Distillation. Distillation is the process of heating a liquid to form vapors and condensing the vapors to form a liquid. It is used to separate two or more substances present in a liquid or purification of water. The apparatus used for distillation is shown here. Let's see the demonstration. Take some salt water in a retard and heat it till the water gets converted into steam. The steam is collected in a beaker which is connected to the retard as shown here. The steam condenses into drops of water and the salt is left behind the retard. Simple distillation is a process by which two liquids with different boiling points can be separated. This can be used effectively to separate liquids that have at least 50 degrees difference in their boiling points. Distillation. Fractional distillation is used for the separation of mixtures of two or more miscible liquids for which the difference in boiling points is less than 25 Kelvin. The apparatus for fractional distillation is similar to that of the simple distillation, except the fractionating column is fitted in between the distilling head and the round-bottomed flask. Materials required. Materials required are the mixture of ethanol and water, 250 ml and 100 ml of round-bottomed flasks, stand with a clamp, fractionating column, distilling head, porcelain chips, thermometer adapter, water condenser, vacuum adapter and heating mantle. Procedure. Take a mixture of ethanol and water and pour it into 250 ml of round-bottomed flask. Take some porcelain chips and put into the mixture. Now, connect the fractionating column to the round-bottomed flask and clamp it. Now, connect the distilling head to the fractionating column and thermometer adapter containing thermometer to the distilling head. Connect the water condenser to the outlet of the distilling head and clamp it. Now, connect the vacuum adapter to the vacuum condenser and a 100 ml round-bottomed flask to the vacuum adapter. Clamp the round-bottomed flask and place it in a beaker containing water. Now, connect a rubber tube between the inlet of the condenser and the tap to allow cold water to enter. Connect another rubber tube to the outlet of the condenser to pour hot water from the condenser to the sink. Open the tap so that water flows through the tube and fills the condenser and then comes out through the outlet. Set the temperature of the heating mantle and heat the contents of the round-bottomed flask. At 78 degrees Celsius, ethanol vaporizes and the vapor rises through the fractionating column and pass through the condenser and the condensation takes place and ethanol gets collected in the receiver flask in the liquid form and water is left behind the distillation flask. Therefore, the separation of two or more miscible liquids for which the difference in boiling point is less than 25 Kelvin can be done only by fractional distillation. Since ethanol and water form an azeotrope, the distillation has to be repeated to obtain the pure components. Applications of fractional distillation. Fractional distillation is used in petrochemical industry to obtain different fractions of petroleum. Second one, to separate the different gases from air. Next, to distill alcohols, etc. Next technique is chromatography. This is also one of the methods of separating mixtures. Before we discuss this technique, we will take a look at the difference between two important terms, absorption and adsorption. Absorption. Absorption is a process in which the substance is uniformly distributed throughout the bulk of another substance. Got confused? I will make it crystal clear with some examples. Watch and enjoy. Now, let's see some examples for absorption. It will be more interesting. Are you ready to listen? Let's take an example, sponge. It has lot of holes or pores in it. We are going to dip the sponge in water. Now, the question is, what will happen if we dip sponge inside water? The obvious answer is, the sponge gets soaked up in water. What exactly happens? In one substance, that is sponge, the another substance, water, is entering and penetrating through the surface and evenly distributed throughout the bulk of the sponge. When we use the word bulk, the water gets uniformly distributed throughout the sponge. Now, you would have understood the concept of absorption. Now, tell me, what is absorption? Yes, the phenomenon in which when one substance enters into another substance and gets uniformly distributed throughout the bulk is known as absorption. Shall we see some more interesting examples? You may have the habit of dipping biscuits in tea for your breakfast. This is an example for absorption. The more interesting example is, you would have noticed your mother making gulab jamuns. She used to fry jamuns in ghee and she will drop it in the sugar syrup. Here, all the sugar molecules are penetrating through the surface of the jamun and evenly distributed throughout the bulk. So, any part of the jamun you take, it tastes the same. Another example is chalk dipped in water. Now, let's take the first example, sponge and water. When we take the sponge and water, which is absorbed, yes, the water is absorbed throughout the bulk. So, the water is known as absorbate. Whereas, the substance which absorbs, that is sponge, is called absorbent. Now, you would have clearly understood what is absorption. Now, shall we discuss about adsorption? I would like to put a question to you. Can you see a person writing on the board? Now, the chalk powder is getting stuck on the board. The question is, can we call this process absorption? No. If it is an absorption, the chalk powder might have penetrated throughout the board and would have uniformly distributed throughout the board. It means, even after erasing the board, the chalk powder should be on the board. Is it that the case happening here? No. In this, there is one substance that is blackboard, and another substance, chalk powder, is accumulating only on the surface. That is, chalk powder is getting accumulated on the surface of the board. Such a phenomenon is called adsorption. Shall we define what is adsorption? It is a phenomenon in which one substance accumulates on the surface of the other substance in high concentration. Shall we repeat once again? It is a phenomenon in which one substance accumulates on the surface of the another substance in high concentration. Shall we see some more examples? If you go to the showroom to buy a pair of shoes, you might have seen some packets inside the shoes. What is that? It is nothing but the silica gel. Next question is, why do we keep silica gel inside the shoes? Recently, I have read in the newspaper that during the lockdown period, in so many shops, the leather items were spoiled due to fungal growth. Fungus grows on the leather items due to the presence of moisture. These silica gels will absorb the moisture in order to prevent the fungal growth. We add up the silica gel. Silica is a very good adsorbent. The substance which is being adsorbed, that is chalk, is called adsorbate, and the substance which adsorbs, that is blackboard, is adsorbent. Chromatography. Let's see what is chromatography. Chromato means color, graphy means to write. Chromatography was first invented by the scientist named Michael Tesvet. Chromatography is also a separation technique. It is used to separate different components of a mixture based on their different solubilities in the same solvent. There are several types of chromatography based on the above basic principles. The simplest type is paper chromatography.